Welcome to Ask and Learn.
This is the answer to Chapter 21, problem number 38 from the Smith Organic Chemistry textbook. And this problem asks us a series of questions about glucose not glucose. This problem asks us a series of questions about galactose. The first question is how many stereogenic centers are present in alpha D-galactose. And so I'm going to go ahead and just label each of those stereocenters so that they're readily apparent. So I will arrow them. So this carbon, this carbon, this carbon, that carbon, and that carbon are our stereocenters. And so there are 5 of them. So then next for B, we're asked to identify the hemiacetal here. So I will do that in red. So the hemiacetal is this carbon here. It's bound to 1 alcohol and 1 ether. And so that's the definition of a hemiacetal. So there it is. For C, we're asked to draw beta D-galactose. So beta D-galactose, so I will label this one A. So then over here, I'll draw B. Oops. So here is beta D-galactose. Oof. So this is B, again, beta. And the only difference is going to be in the stereochemistry at that hemiacetal carbon. And so everything else is still the same. And then here, the carbon has the opposite stereochemistry. So it's an equatorial group for beta, and in alpha, it was an axial alcohol. And so that's the answer to part C of this problem. For part D, we're asked to draw, So for part D, we're asked to draw the polyhydroxyaldehyde that cyclizes to form galactose. And so I'm going to draw that like this. So we could just draw it as an open chain, but the benefit of drawing it this way is it's easier to see how it actually ends up cyclizing when you draw it like this. Okay, so there we go. There's the answer to part D. And then lastly, for part E, we're asked if we were to treat alpha D-galactose with methanol and an acid catalyst, what products would we expect to get? And so the answer to that, to part E, I'll put down here. So the products that we should expect from treating this alpha D-galactose with methanol and acid are going to be replacement of that hemiacetal alcohol with a methoxide group. But it is important to note that we're going to get a mixture of the stereochemistries there. So the one that we might expect or would probably expect would be this one, OCH3, where the alcohol has just at least apparently been directly replaced by the methoxide. But we would also get the opposite stereochemistry. So we started axial there, and the alcohol was axial and the methoxide is axial. But we will also get the product where we started with the alcohol axial, but we're actually going to get the methoxide in the equatorial position. And again, the explanation for that can be found in chapter 21.16b from the textbook. So basically, we're protonating the alcohol, it's leaving, the carbocation is forming, and then the methanol is able to attack that carbocation from either side. And that accounts for this mixture of products. And so that's the answer to part E. And overall, that's the answer to chapter 21, problem number 38.